magazines making stories about critically endangered animals. The animal on the left side you see is Derby eland, western subspecies, which is critically endangered and living just in 2 reserves in the whole world. Can you imagine that? This is in Senegal, and the picture at the right, maybe you guys in Indonesia, you can guess what the footprint is there. So I'm not gonna tell you what was the species I was tracking and trying to take a picture of it. And maybe you can, I will leave you my contact at the end, and maybe you can post me maybe you can send me some tips what animals I was searching for. So this went to let's say some high quality outcomes from my side, but in one very important moment I realized that it's not really enough to take beautiful pictures of beautiful animals, but the most important thing is how we will simply how to simply contribute to conservation of such kind of animals. And that's why I realized that it's maybe my time to come back to university and finish my PhD study and do something really substantial, something important for conservation, and hopefully simply contribute somehow. So I did. I quit all my jobs in media, and I came back to Czech University, or I came to Czech University of Life Sciences. And I proposed them that my PhD topic can be something connected, very connected to taking pictures and with my passion and love for traveling and searching for the most endangered animals in the world, how to simply connect it. So I was really in the right moment on the right place, and we are still we are at this very moment, and we are simply witnessing last, let's say, 20 years when this kind of thing like a camera trap became really standard in wildlife monitoring, standard in field research, and how simply this kind of tool for zoologists, for guys who are, for zoologists and for conservationists. So this tool is became really essential. So and I will explain you what we can expect out of this, how we can treat the data, how we can simply use it in the field, how we can cooperate through this kind of approach. What we've done at our faculty is that we established wildlife monitoring services team. Here you can check the website. We are actually even offering some of our services to wildlife authorities, to universities, to managers of protected areas, let's say. And what we can do is that we simply can monitor the wildlife living in some areas through some very specific methods which are globally recognized. So how did it happen that camera trap took over, has taken over how did it happen that it became so important tool? What is camera trap? Actually, as you can see, really just here, camera trap is nothing more than a camera connected to passive infrared sensor and the temperature actually and movement is a trigger through that sensor. It triggers the camera. So you can see all those varieties of camera traps used everywhere, but this picture is very illustrative and to simply know what we are talking about. This chart is quite impressive because what you can see here, it's ending in 2000, I guess 2017. I don't see that, but you can expect this exponential growth that that it will continue. It's not of course getting to plateau, and you can see how many researches were published globally from the year of 2000 to 2017, and you can see this exponential growth, how this camera trap became so important to because from, let's say, the year of 2000, there happened one very important thing, and that thing is that camera traps became from analog, they became digital, which means that you don't really care about the film strips in the cameras. The price of this tool decreased substantially, and so on. So now it's you can get one very good camera trap for the price, let's say about $100 US, let's say, nowadays. So there is a huge variety of camera traps you can find on market, no doubt. There is no big reason to talk about this more. You can find camouflaged ones. You can find camera traps which are even used in aquatic system. You can have a camera trap at the right side which can take 180-degree angle record. So simply you can see everything from both sides of the camera. So every animal passing by is recorded. You can have camera traps which are connected to GMS or even a satellite system, and they are sending the pictures right from the field. So there is no big reason to talk more about the variety of camera traps. Everything can be designed, or for each purposes you can find a tool which is usable for you. Of course, camera trap became a big business. There is I don't even know how many, even in Czech Republic, which is a very small market. So we have for sure hundreds of shops, online shops, which are selling different models and different marks of camera traps. And of course, hunters, they love them. Of course, people who are owning the properties somewhere in remote areas where they cannot be there. So these camera traps provide surveillance and they are guarding the properties of people. But simply, we are on academic field, we are on academic soil, we are doing research. So the most important thing for us is, or can be started with, let's say, this book. That's very good guidebook for everyone who is willing to use camera traps as a researcher. So I really recommend this book, which is not really cheap, but really essential for everyone. And you can get very concentrated, very dense information about all the things connected to camera traps and the research. The most important thing is, you want to use camera traps somewhere okay, so what you're going to do with these camera traps? You have to design the survey. You have to design the study for you. Of course, it's with every research you have to think twice. Simply, what the methodology will look like, how it will look like, what data you are getting, what data you want to simply report out of this research. And we can say that there are just basic layout, let's say, or design for camera traps, as you can see here on this example, on this picture. You can place the camera traps simply randomly. Let's say you have 100 points where you want to place the camera traps in certain area. This green places can be considered as a let's say university forest, somewhere where you wanna get the information what is living in the forest there. So okay, you can place them completely randomly, which is on the left side. Or you can use some systematic placement of the camera traps. That, let's say, all the area of the forest will be surveyed. All the area will be in every corner of your forest. There will be the same probability that the animal or poacher or simply the object you are interested in will meet the camera trap. And you can spread the camera traps all around the area, or you can make such kind of clusters as you see on the right side. And in these clusters, you will sample the area with the camera traps. For just to show you, this is very in my example, what we've done in Senegal, in the national park near Kolokoba. All those dots and pluses and circles are places where we put the camera traps, and we were interested in core area, in the central area of the national park, which is considered as the most well preserved area where all those important animals or endangered animals should be living. So we were focused on this very area, and we covered this area with something like 50 camera traps or something like that. Well, but we are in Sundaland, actually. So, as Tomáš mentioned before me, Sundaland is very diverse. And I've never been to Sumatra, I have to admit, but I've been to Kalimantan, I've been to Java. I've been to Philippines, which is not the Sundaland, but still, let's say, the region. And simply to show you what designs were used in this area in past years. Here we can see a study of Sunarto in Sumatra, who was interested in getting information about the cat species from the very small cats to up to tigers. You can see those white clusters in the map. Each cluster has a systematic placement of camera traps. So they put 1, 2, 3, 4, 5 of these sampling clusters in the areas, in the protected areas. Here we can see, and they were analyzing what is the community of the animals living out there, and then they were analyzing the co-occurrence of cat species. There is another example from Sundaland. This is from Java. This study of Aryo in 2007 was focused on Javan leopard. And you can see that they used some kind of quadrates, and in each quadrate there was a placement of camera trap in the most probable place that they will encounter, that they will record the Javan leopard. And not finally, of course, but one example from Borneo, I guess Malaysian part. There was a research which was focused on clouded leopards and other cat species. They finally got the picture of clouded leopard, but they were placing camera traps even in canopies, as you can see here, because of course cat species are they like to climb, they like to even use they really love wooden substrate, we have to say, because if you have some fallen trees somewhere in the forest, there is quite big chance that you will encounter cat species in the area. So actually now we are preparing some kind of design for one study in mangroves, which is one of the fastest disappearing ecosystem in the world. And the camera traps and the use of camera traps in that kind of environment, which is flooded regularly, of course, is really a challenge. But we are really progressing somehow. And this use of camera traps in a canopy will be the main design how to survey this area. So, but there is another example from the area. This is my study, or our study, in the Philippines, what we've done. You can see those circles in the map. This is on island of Bohol in the Philippines. And you can see those circles. In those circles, there are camera traps placed. And as you can see, the camera traps are not randomly covering the area. So why we did this kind of design, the reason was very simple. We were interested in feral cats. These cats, domestic cats, these cats are visiting the natural habitats, and they can be hunting for local species. As you can see those numbers there in zone 1, zone 2, zone 3. And you can see those species on the left side. So you can easily see that the biggest numbers, except of rats and mice, so the biggest numbers of records of animals are those with ground-dwelling birds. So the bird species, which are generally flying, of course, somewhere, and we are not finding these species on the ground. Actually, we found out that even such kind of species like a tarsier, which is an animal even living in the bushes and jungle in Indonesia. So even this animal can be encountered, can be recorded with camera trap. And quite big number of bird species can be also recorded by camera traps on the ground. So when we will be talking about designing some kind of study in Sundaland, from Java to Papua, so each place we will be surveying really needs consideration, really needs proper preparation of the design, because we really should know before what species we can encounter there, and even for quite big number of ground-dwelling birds, or birds simply which are sometimes present on ground. So even this kind of study can be designed even for birds, not just for mammals, which is the, let's say, 90% of all the maybe 95% of all the camera trap studies. So here on this example from Philippines, you can see how important it can be for birds as well. Well, but okay, so we designed the study, we conducted the study, we put the cameras in the forest, then we came back, we collected everything, hopefully, if nothing got stolen or destroyed or whatever. And we are taking the data back home. You have to really be prepared that we are dealing with a huge amount of data, a huge amount of even space for the data storage, not just the data itself, but the space. You can see 3 examples here. 1 month in a study in Czech Republic in a forests we do here, we can have something like almost 10,000 pictures. Is more than a half, which is really a huge number. Let's say 6,500 records of animals. But these 10,000 pictures, that really means it's like 14 gigabytes. So you really cannot be expecting that you will transfer such kind of data via GSM modules in camera traps. You really have to physically download the data, put them on a disk, come at home with this kind of data, and you have to store them somewhere, and then you have to start the processing data. In Congo, in 3 months, we got something like 56,000 pictures, 74 gigabytes, and only something like 17,000 records of animals, which is, you can really see that can be really frustrating, because you are simply recording some area. And even in Senegal, during 6 months, we have just only something like 10% of all the records by camera traps are animals. So you have a huge amount of blank, just empty pictures with nothing, and you have to deal with it. So here on the you can see how you can treat the data. Let's say when you have time and when you have manpower to do so, you really have to physically go through all these records, and you have to divide the records. You can put the birds in one folder, wild boar in second folder, and so on. Well, okay, we have this done, and now we have a huge amount of data. Of course, we are using such kind of tools like Excel and softwares. So each row in this sheet represents one record of animals. So you can have this kind of sheet which has something like 35 or 17,000 rows actually, where you will know each row is a image, and each row represents one picture with some species of animal. So what to do with this kind of, how to report this huge amount of data? One of the most important things is sampling effort, which means number of camera traps multiplied with the duration of the study, with the number of days. So you will get some kind of trap nights or trap days, doesn't matter. If you have, let's say, 40 camera traps and you sample some area for 100 days, so you will have 4,000 camera trap nights. Of course, one of the most important things why we are doing this is that we are getting the number of species recorded somewhere. As you can see here in the graph, you see the blue line, which is denoting, which is highlighting 1,000 trap days. That's some kind of threshold. When you sample some kind of area, the curve which is going through here, so it shows how many species is recorded in during the certain duration of the sampling. So you can see that in the beginning the increase is really huge. You can get, let's say, in first, let's say 200 trap days, you can get almost 20 species. When you sample that area for 1,000 trap days, so you are getting almost the final number of species in the area. You have something like 30 species out of 35. When you continue with the study for 2,000 trap days, so in those last 1,000 trap days, you will get only, let's say, 5 most secretive species or most endangered species at the end. So this graph is very important, because for you really have to count with when you have some number of camera traps and expected duration of the study, so you can see how many animals you can simply guess how many animals you will how many species you will have. And like one of the basic measure you will report is of course when camera trap is recording, when it's capturing some let's say animal, okay, some for instance a tiger. Will you know how many tigers you will have there? In case of tigers, you can know this because tigers, they have certain pattern of stripes, which is unique for each individual. So out of this, you can really know how many of this kind of animal you will have there. But if you will, let's say, record a deer which has no pattern on a flank, so you really don't know how many of them, how many individuals you will have. But because you know the duration, the sampling effort, you know how many trap days you did the study, so you can do very important equation, and that is relative abundance index. Abundance is how many animals is living there. Relative is it because you don't know the real number. You don't know that there is a 500 deer in the forest, but you will know that there is some kind of number of deer and some kind of number of some other animal, let's say water chevrolet, for example. All the records you are having from the study, you have to make them independent, which means that when there is a camera trap and when there is a deer passing by the camera trap, so you will have the deer is passing by the camera trap for a certain time. So you will have, let's say, 10 pictures of the same deer who is still passing by. The problem is that this record is, all those, let's say, 10 pictures are not independent because they are made by the same animal. So you have to take this event as independent. And how to make it? You will divide that kind of record of animal with certain time in between. You will consider independent record, let's say, when 2 records of the animal are separated with, let's say, 1 hour or 30 minutes. It's up to you. It's up to a species, actually. So you will make these kind of records independent. And when you have this event, so when you have the number of events of records of the deer, so you will divide them with the number of trap nights, and you will get that kind of number, which is here 39.37. This is very relative number, but you can see that the first animal, I'm sorry, it's in Czech, but the first animal is deer, and the second animal with the 7.5 is a roe deer. So you can see that there is a quite big difference in the numbers, the population of these 2 species. So you can really see that the roe deer is less abundant than the deer, which has the 39 RAI. And when you will make this study 1 year, second year, another year, and you will have, like, let's say, 3-year data, so you can see how this relative abundance index number will change in time. And when you see that this number goes down, so there is something problematic with the population, and the population is declining, actually. I hope this was clear. Of course, we can discuss everything online, and let's skip to other things. For reporting the camera trapping data, there are certain softwares. I'm using this one, Camelot, which provides you with, you are simply treating those pictures in this software, and this software is providing you with full reports, as we saw before, like relative abundance index and such. So you don't need to make it manually, let's say. Of course, there is some kind of thing which can be called bias. Bias is a problem everywhere in science. It means that your data are somehow, that your outputs of your research, your results, can be somehow negatively influenced by something. The camera trap is a great tool, but not just human is a really curious animal, but of course even monkeys, even giraffes, even many other species are very interested in what is the camera trap. So they can be even attracted by the camera trap, and they can be simply just taking selfies there, as you can see the monkey. And then your records can be somehow, you have to know that this can happen, and your records can be somehow influenced by even behavior of animals. Contribution to conservation of camera traps. Well, this is your homework. You will send me the answer. What is the species of this animal discovered to the world by camera traps, and what is the name of this species introduced to the world with use of camera traps? 3, 2, 1, continue. From my own research, the contribution to conservation can be this kind of pictures. Let's say this Derby eland in the wild. It's in the National Park of Neokolokoba. You saw the design of the study before. It can be this Ussurian tiger in Russian Pacific area. But the important thing is that through the records of camera traps, there are something like global initiatives, global database, which are producing results. And these results can be considered some kind of witness, of the state